Good morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Morrow's Algebra I class. Today we are going to continue solving quadratic equations, but this time we're going to be using the square root method. So far, we have two tools for solving quadratic equations. We can graph it, and we can estimate the x-intercepts, or we can factor the the quadratic equation, find the zeros right there by factoring using the zero product property. And then if we wanted to, we could graph on top of that. Okay? And then today, we're going to learn how to solve by using square roots. Now, in order to solve quadratic equations in the form of y equals x squared plus c, notice that there is no b value here. There is no x value by itself. It's just an x squared, maybe a coefficient in front of the x, and a c, a real number. In order to solve that, simply take the square root is that symbol right there, of both sides. When you take the square root of both sides, the power of 2, the exponent, cancels, and the answer will be in plus or minus. Let me explain that plus or minus part. If I have the square root of 9, gentlemen, what is my answer here? No, it's plus or minus 3. And let me explain why. What is 3 times 3? What is negative 3 times negative 3? 9. So do you see that the square root of 9 can come from two positive 3's being multiplied together or two negative 3's being multiplied together? When you're dealing with a square root, the goal, okay, is to find what number times itself gives me this value in here, which is called the radicand, okay? That's the goal. So when I have a square root, I'm looking for pairs of numbers. For example, the square root of 25 could be plus or minus 5. Why, Mr. Morrow? Because 5 times 5 can equal 25, or negative 5 times negative 5 can equal 25. Now, if anyone is still confused, think about it like this. You can break down 25 into 5 times 5. When I have a square root, every pair of the same number comes out as one of the value. So I have a 5 and a 5, so that's 1 5 that came out. That could be a positive 5 or a negative 5. And that's how square roots work. Does that make sense? Okay. For example, what if I just told you solve x squared equals 81? Well, I want to get the x by itself. So I got to get rid of that power of 2. And in order to get rid of that power of 2, I take the square root of both sides. When I take the square root of both sides, the square root symbol cancels out the exponent. So I'm left with x equals 81 breaks up into 9 times 9. A 9 and a 9 comes out as 1 9, but it's plus or minus because 9 times 9 is 81 and negative 9 times negative 9 is 81. Now, how does this relate to what we've been doing, Mr. Morrow? Check it out. What are my zeros? What are my solutions? What are my solutions here, guys? 9 and positive 9. Those are the x-intercepts, correct? Those are my zeros, my x-intercepts, or my solutions, correct? Okay. Here, when you have this in standard form, x squared minus 81 equals 0, what's the y-intercept? The y value when x is 0? Negative 81. And guess what, guys? That's my parabola. Just making sense, guys. I've been trying my best to relate every section to the graph so you can understand exactly what's going on. So you can understand the mechanics of this graph. Does everyone understand this? You see how it relates to the graph. You promise. Okay? Let's continue then, please, gentlemen. Solve. Okay, what do we do first here? I want to get x alone. Very good, sir. You want to divide 3 to both sides. So x squared equals 27. How do I get that x alone now? Square root both sides. The square root cancels the power. X equals, wait a second. Is 27 a perfect square? Okay, that's where you got to remember. Every pair of the same number comes out as one of that value. So how can I break down 27? 3 times 9, 3 is prime, circle it. How do I break down 9? 3 times 3, prime, prime, circle it. You are only dealing with the circled numbers at this point. You with me so far?
Yeah.
Okay. Every pair comes out as 1, right? So this is going to equal a 3 and a 3 comes out as 1, 3. And what do I have left over? A 3. This guy. And that's how you simplify square roots. What's my big mistake here? Plus or minus. Does that make sense, gentlemen? You promise? Okay. So now let's wrap it all together. In order to solve quadratic functions or equations using square root method, the function, first of all, must be in standard form, which is going to be y equals ax squared plus c. Please notice that there is no bx. You cannot use this method for one of these. You cannot use the square root method here. You cannot use the square root method here. Why? Why can you not use it? Because of this. When you have the square root method, you only have the x squared value and a regular real number. Does that make sense? Okay. So there is no bx because the value of b is 0. When the function is in the above form of y equals ax squared plus c, simply set y equal to 0 and solve for x. We know how to solve for x. You take the square root of it. Your solutions are the x-intercepts. They're also known as the zeros. So let's solve each quadratic function. Okay, first things first, let's make that y 0. X squared minus 64 equals 0. Now I want to get the x alone. So I'm going to add 64 to both sides. X squared equals 64. I want to get the x alone, so I square root both sides. The square root cancels the power of 2. So x equals plus or minus 8. Because 64 is a perfect square. And again, what does that mean, Moro? It means this. I have a y-intercept at negative 64, and I have a 0 at 8 and at negative 8, and that's the graph. Does that make sense, guys? Putting all these pieces together, hopefully it's making things easier. Okay, number 2. First things first, got to set that y equal to 0. So I got 3x squared minus 27. Now what? Now you want to undo addition subtraction first, right? In a two-step equation. So add 27. Now what? Divide by 3, thank you. 9 equals x squared. Square root both sides. X equals plus or minus 3. Makes sense? Okay. Number 3, what do you want to do first? Subtract 25. 0 equals 5x squared. Now what? Divide by 5. Very good. 0 equals x squared. Square root both sides. What does x equal? Why do I not put a plus or minus on 0? Very good. 0 is not neither positive nor negative. It's neutral. Next, what do I do here, my brothers? First, make the y 0. Now, not subtract 10, add 10. Good. So I got 10 equals 2x squared. Divide by 2. 5 equals x squared. Square root both sides. X equals plus or minus the square root of 5. Can I break down the square root of 5 at all? No. So when you have a situation like that, you leave it as the plus or minus square root of 5. Number 5, I make my y 0. That equals x squared plus 81. How do I solve for x? Subtract 81 to both sides. Negative 81 equals x squared. Square root both sides. So x equals? No. It equals no solution, guys. I'm going to show you right now why. Think about it. Guys, negative 81. What's 9 times 9? What's negative 9 times negative 9? How are you ever going to multiply something by itself and get a negative? It's impossible. So whenever you have a square root with a negative inside of the radical, that is going to be no solution. Now, what kind of a graph is that, Mr. Morrow? Check it out. Check this out. It's something like this. My y-intercept here when x is 0 is 81. Let's just say that's 81, okay? Right? So it's going to go like this. No solution. That means it never hits the x-axis. Is this making sense, guys? Sir. Positive 9 times negative 9 does equal negative 81. But is positive 9 and negative 9, are they both the same number? No. So that's not a square root. To get a square root, guys, it has to be the identical number times itself. So there can never be a negative square root. What's negative 2 times negative 2? 4. Negative 3 times negative 3? 9. Negative 7 times negative 7? 49. You can never, ever multiply a number by itself and get a negative. It is impossible. Thank you so much for verifying that. Does that make sense, gentlemen? You promised me. Awesome. Thank you very much. Hope you learned a lot. Have a wonderful day.